Please invite Ed on up to the stage.
So good morning. Range Networks was founded on the proposition that we can bring software where previously we needed proprietary hardware, where we can bring open source where previously we needed proprietary software. And the benefits of that are not only around greatly diminished cost, CapEx, things like that, but also the idea that we could greatly increase the rate of innovation around mobile. Although we've all carried these around for the last 20 years, when you think about the rate of innovation in the apps that are on the handset and the rate of innovation that are in the cloud, and then the rate of innovation that's actually in the infrastructure, I think we all know that there's been a dramatic mismatch in the innovation inside the infrastructure versus what's on the device and what's in the cloud. So Range is a software implementation of mobile networking. The air interface is standards-based. However, behind the air interface, this device is immediately mapped to IP, and the voice channels are mapped to SIP. So this is a SIP device inside of the software. That means the combination of the software running on commodity CPUs, everything from a small ARM Beagle board all the way up to a multi-core Xeon processor, means that we can provide mobile voice and data communications at extremely low cost. When you combine that with software-defined radios, which are themselves on a path of rapid increasing in capacity and capabilities and a path downward in cost and complexity, you have a device that is not only frequency agile, but also protocol agile. So if you look at the stack here, you see that we've taken the mobile architecture and we've essentially put the internet on top of it using the 3GPP access protocols, 2G, 3G, 4G, and so forth, simply as the access link into an internet-based mobile infrastructure and architecture. So the advantage of that, of course, is that we have all the advantages of software in terms of flexibility. We do the actual baseband processing in software. So that whether it's GMSK, OFDM, wideband CDMA, it's merely software. So that means we can move with the market, we can combine these protocols. Some of the IoT protocols, for instance, such as Weightless, have seen that it's a bit of a mishmash. They take something from GMSK, they take something from wideband CDMA. That means we have the competency to put all those together and implement those in software. When you apply this, that's nice, but what do you actually do with it? Protocol stacks become VMs. They just become virtual machines. And when you combine those virtual machines with a software-defined radio, you now have what looks more like a multi-protocol IP access point than a traditional base station. You are frequency agile, you are coding agile, you are protocol stack agile. And this means that we can take wireless technologies into markets where it was far too expensive to go before, or into applications that are new and emerging. For instance, when we consider Internet of Things is not a market, it's many different markets. It's not one protocol, it's about 20, growing by the week. So it's far too soon to select the absolute winner, far too soon to go to silicon in some of these markets. And the software-based approach, an agile approach, gives you tremendous flexibility in how you solve that problem. When you look at the Range software platform, the company was founded originally to bring low-cost mobile communications to rural, remote marketplaces. At the same time, we actively engaged the university markets, the typical early adopters, the innovators. We open sourced a piece of our solution to bring those innovators into the table. So we have people that are using our technology now for white space applications, for security applications, search and rescue, location, things like that. And we learned that by putting APIs in the platform aggressively, we can invite that innovation community to use our technology. Recently, we've expanded the platform to embrace the enterprise marketplace. Really, it wasn't very much we needed to do because we represent this as a SIP endpoint. It extremely naturally and easily extended into the VoIP enterprise marketplace. And there's an increasing amount of interest in building mobile networks inside of the enterprise, not just extending the operator infrastructure into the enterprise, but actually building a mobile network in the enterprise and then connecting it to operator infrastructure. The benefits of having a mobile network in the enterprise are not only better coverage, there are significant benefits in the area of privacy, the metadata, the call, handling, everything stays inside the enterprise. There are benefits in the area of security. We can do security functions inside of the enterprise that an operator just simply couldn't do from outside of the enterprise, as well as behavior, identity. When this device moves into the enterprise, it assumes a new identity, a new number, so that business calls have a business number and so forth. Outside of the enterprise, it resumes its personal identity. So for a lot of reasons, we believe that the wireless world and the wireless model will expand dramatically. We all see the new spectrum coming to the marketplace. We see the new models for spectrum sharing and spectrum reuse. We see IoT coming to the marketplace. We see a wideband enterprise network marketplace emerging, but at the same time we see the service provider models emerging. And what we need is a flexible software-based, software-defined platform, and we see a great opportunity around that. And I put up a few of the early adopters here on this, and I'll finish with that.
Great, thanks Ed. So we went over time, so you have to save your questions for the break, guys.
Thank you.
All right.
All right.
So that is a snapshot of how our investor